Have you ever wondered what exactly a black hole is? A black hole is one of the universe's most mysterious phenomena. Simply put, a black hole is a region in space where gravity is so strong that nothing, not even light, can escape it. You might ask, how does a black hole form? Black holes are born from massive stars much larger than our sun. Inside these stars, nuclear fusion produces energy pushing outward, while gravity pulls everything inward toward the star's center. For millions of years, these two forces balance each other. That is what keeps a star alive. But eventually, the star runs out of fuel. Without fuel, the outward pressure fades and gravity wins. The star collapses under its own weight, crushing its core, compressing space itself until a singularity is formed, a point of infinite density where the rules of space and time as we know them no longer apply. Now you might be wondering, can anything, even humans or objects like laptops or planets, be turned into a black hole? Technically, if you could compress enough mass into a small enough space, gravity would dominate. And yes, theoretically, anything could become a black hole. But let us come back to the black holes that exist in reality. Those are the ones created naturally, by collapsing massive stars or by collisions of stars, and even merging black holes. All of them form cosmic monsters that warp space-time and bend light in unimaginable ways. Imagine approaching a black hole. Its boundary, the event horizon, is the point of no return. Cross that line and not even light can escape. Outside observers would see you slow down, almost frozen in time, while in reality you would continue falling faster and faster. Inside, darkness dominates and gravity stretches everything, compressing even empty space toward the singularity. What happens next? How does it feel to reach the heart of a black hole? As we cross the event horizon, everything changes. The light from outside can no longer reach us, and the universe behind appears twisted and circular. You would see yourself in ways you never imagined. Light bends around the black hole, making it possible to see the back of your own head, the space above and below all at once. From an outside observer's perspective, your movement seems to slow down, almost frozen in time, while you continue to fall deeper at incredible speed. Gravity inside the black hole grows stronger with every moment. It stretches and compresses everything around you, even the empty space between atoms. Your body, matter, and even time itself are pulled toward the singularity, where the density becomes infinite. Everything merges into a single point. No human has experienced this. No experiment has taken place. This remains a theoretical journey, a glimpse into the unknown. As you approach the singularity, space and time lose all meaning. The concepts of up, down, past, and future no longer exist. Gravity compresses every particle, every atom, leaving nothing behind. The empty space, the distance between atoms, vanishes as everything converges. The singularity awaits at the center. It is the ultimate end, where matter becomes one with the black hole and the laws of physics as we know them collapse. Yet from outside, the black hole continues to influence the universe. Its gravity, its warping of space-time bends light, pulls stars, and shapes galaxies. We can never survive falling into a black hole, but studying them helps us understand the universe, gravity, and the mysteries of space and time. This is the power and the danger of a black hole. Crossing the event horizon is stepping into the unknown, a journey from reality into the singularity, where everything familiar disappears. Falling deeper into the black hole, the forces become extreme. The gravity at your feet is stronger than the gravity at your head, stretching your body into a long, thin shape. Scientists call this effect spaghettification. No human has experienced this, but theoretical physics predicts it with precise calculations. Every atom in your body is pulled toward the singularity at different rates. Even the strongest materials would be stretched and torn apart. Your body, your spaceship, or any object cannot resist the gravitational pull. Time also behaves strangely. From your perspective, moments continue to pass normally, but from the outside it appears as if you are frozen. Light from the outside universe bends and swirls around you, creating a distorted view of reality. The closer you get to the singularity, the more extreme the conditions become. Space and time collapse, and the distance between everything diminishes to nearly zero. No signal can escape, no information can return. The black hole consumes everything, leaving only the singularity. Yet black holes are not merely destructive. They play a vital role in the universe. They influence star formation, guide galaxies, and help scientists understand gravity and space-time. Even though we cannot survive inside, studying black holes allows us to explore the laws of physics at their limits. It challenges our understanding and expands our imagination. As we approach the singularity, the universe as we know it fades. Concepts of space, time, and matter cease to exist. Everything merges into the core of the black hole, a point of infinite density. This is the ultimate fate inside a black hole, a journey from the known into the unknown, where physics meets mystery, and reality is transformed beyond comprehension. As we move closer to the singularity, strange and extreme phenomena appear. Black holes are not empty. They are surrounded by intense gravitational fields that warp space and time. One effect is gravitational time dilation. Time slows down drastically near the black hole. From your perspective, seconds pass normally, but to an outside observer, years or even centuries could appear to pass. Another effect is the bending of light. Light from nearby stars curves around the black hole, creating rings and arcs, known as the photon sphere. If you look outward, the universe appears twisted and circular. Black holes also emit radiation, called Hawking radiation, caused by quantum effects near the event horizon. Although it is tiny for massive black holes, it is a crucial clue for scientists trying to understand the connection between gravity and quantum mechanics. Matter falling into the black hole heats up, emitting X-rays and gamma rays. This allows astronomers to detect black holes indirectly, even though the singularity itself remains invisible. Tidal forces near the singularity are enormous. They stretch and compress objects, and even light is forced to follow curved paths. The structure of reality bends in ways we cannot fully comprehend. Despite these dangers, black holes are essential to the universe. They influence galaxy formation, regulate star movements, and create environments for extreme physics experiments, at least theoretically. Studying them helps us probe the limits of Einstein's theory of general relativity and modern physics. Black holes remain both destructive and illuminating, offering a glimpse into the deepest mysteries of existence. As we approach the heart of the black hole, all known laws of physics are tested. Matter, energy, space, and time converge toward the singularity, leaving nothing as it was before. This is the ultimate environment of a black hole, a place where the universe stretches, bends, and transforms beyond human comprehension, yet continues to shape the cosmos around it. Now let us imagine a human falling into a black hole. First, the event horizon is crossed. At this point, escape is impossible, and all communication with the outside universe ceases. From an outside observer's view, the human appears to slow down, almost frozen in time, never fully crossing the horizon. Yet for the person falling, movement continues normally, accelerating toward the singularity. The gravitational forces stretch the body vertically and compress it horizontally. This spaghettification effect grows stronger as the singularity approaches. No structure, no material can resist these forces. Even at the atomic level, matter is compressed and stretched. Empty space between particles diminishes, and the body merges into the singularity. It is a complete transformation of matter and energy. Time itself becomes distorted. Seconds and minutes lose meaning. Past, present, and future converge into the singularity, creating a reality unlike anything we have ever known. No human could survive this journey. It is a theoretical experience, explored only through physics and mathematics. Yet imagining it allows us to understand the extreme power of gravity. Black holes challenge our perception of life and death, reality and imagination. They are not merely cosmic monsters. They are natural laboratories testing the limits of space, time, and matter. As the human approaches the singularity, The universe outside continues. Stars orbit, light bends, galaxies move, and time outside proceeds normally. Meanwhile, inside the black hole, matter and energy reach the ultimate limit. This is the final stage of falling into a black hole, a journey from the known world into absolute extremity, where survival is impossible and reality as we understand it ceases to exist. The black hole transforms everything, making it a singular point of infinite density, a place where physics meets the absolute unknown. Inside and around a black hole, light behaves in strange and fascinating ways. Gravity is so strong that light no longer travels in straight lines. It bends, curves, and even orbits the black hole in a path called the photon sphere. If you were near this region, the universe would appear warped and circular. You could see the back of your own head, stars looping around and distant galaxies twisted in arcs. Black holes also affect radiation. Matter falling into the black hole heats up, emitting X-rays and gamma rays. This radiation escapes the black hole's gravity before crossing the event horizon, giving astronomers clues about its presence. Even the vacuum of space is affected. Space-time itself is stretched and curved, creating a gravitational well so deep that it warps everything nearby. Time slows down near the event horizon, and extreme tidal forces pull and stretch matter. These effects are not just destructive, they reveal the universe's most fundamental laws. By observing light, radiation, and space-time near black holes, scientists test Einstein's theory of general relativity and explore quantum mechanics. Approaching the singularity, all known physical limits are challenged. Light, matter, and energy converge. Space-time becomes infinitely curved, and all distances shrink to zero. From the outside, the black hole remains invisible, yet its influence is profound. Stars orbit differently. Galaxies form and evolve, and cosmic structures are shaped by its gravity. Black holes are both destructive and creative. They are laboratories for understanding the cosmos, extreme physics, and the limits of our universe. As we continue this journey, we see that black holes are not merely points of destruction. They are gateways to understanding space, time, and the mysteries that lie at the edge of reality. As we cross deeper into the black hole, questions about matter and information become central. The singularity is a point of infinite density, where all the matter that has fallen is compressed into nothingness as we understand it. One of the biggest mysteries is what happens to information. According to classical physics, information about the objects that fall in could be lost forever. Yet quantum mechanics suggests that information must be preserved. This is the essence of the black hole information paradox. Matter falling into the black hole experiences extreme compression. Atoms are stretched and squeezed, and the empty space between them disappears. Eventually, all matter converges toward the singularity. Time itself behaves unpredictably. From an outside observer's view, objects appear frozen near the event horizon, while inside they accelerate toward the center. Past, present, and future merge, and the familiar flow of time breaks down. Some theories suggest that matter could be transformed into energy, or new forms of particles inside the singularity. Others propose that black holes might connect to other regions of space-time, creating hypothetical gateways, like wormholes. Despite all these possibilities, the reality is unknown. No human, no probe has ever crossed a singularity. All we have are mathematical models, simulations, and observations from outside the event horizon. The black hole continues to consume matter and bend space-time around it. Its gravitational pull shapes the orbits of stars, guides the formation of galaxies, and stretches light into arcs and rings. By studying black holes, we explore the edge of reality. They test the laws of physics, challenge our understanding of space and time, and push the limits of imagination. Falling into a black hole is a journey from the familiar to the extreme unknown, where matter, energy, and information converge into the heart of singularity beyond human comprehension. As we approach the deepest regions of the black hole, the ultimate fate of any observer becomes clear. Once past the singularity, Conventional physics no longer applies. Matter and energy are compressed into a point of infinite density. Hawking radiation provides a fascinating twist. This radiation is emitted near the event horizon due to quantum effects, allowing black holes to slowly lose mass over time. In theory, this could mean that black holes eventually evaporate, releasing some form of energy and possibly information. For someone falling inside, the experience is extreme. Tidal forces stretch and compress the body, time distorts, and the familiar laws of reality break down. Everything converges toward the singularity, leaving nothing behind. Yet information might not be lost completely. Some theories suggest that it could escape through Hawking radiation or exist in a transformed state at the edge of the black hole. This remains one of the greatest mysteries of modern physics. From outside, the black hole appears stable, pulling in matter, bending light and shaping space-time. From the inside, reality unravels, and the singularity becomes the ultimate convergence point for all matter and energy that has fallen in. Black holes challenge our understanding of the universe. They are both destructive and revealing, offering insight into gravity, quantum mechanics, and the structure of space-time itself. The closer you get, the more extreme the conditions become. Light bends into loops, time slows almost to a halt, and matter is stretched infinitely. Crossing deeper into the black hole is a journey from the known universe into the ultimate unknown, where energy, matter, and possibly information merge at the singularity. This is the extraordinary nature of black holes, the most mysterious and powerful objects in the universe. After exploring the depths of a black hole, we begin to understand its extraordinary impact on the universe. Black holes are not just cosmic voids, they are active participants in shaping galaxies and stars. The gravitational pull of black holes guides the movement of stars, influences galactic structures, and creates the cosmic dance we observe in the universe. Light bends around them, revealing rings and arcs that tell us about their presence and strength. Even though nothing can escape from within the event horizon, black holes provide insight through radiation and their effects on surrounding matter. Hawking radiation hints that black holes might slowly release energy and potentially information over immense timescales. Studying black holes allows scientists to test the limits of physics. General relativity explains how gravity bends space-time, while quantum mechanics tries to explain the behavior of matter and energy near the singularity. Black holes sit at the intersection of these theories, challenging our understanding. For humans, black holes are a reminder of our place in the cosmos. They are dangerous, extreme, and unknowable from the inside, yet they inspire imagination, curiosity, and scientific discovery. The journey toward a black hole is a journey toward the edge of reality itself. From the event horizon to the singularity, every phenomenon tests the laws of physics, from spaghettification to time dilation and warped light. In the end, black holes are both destructive and illuminating. They consume matter, bend space, and warp time, yet they reveal the hidden structure of the universe. They remind us that the cosmos is far stranger, more powerful, and more mysterious than we can fully comprehend. Understanding black holes is a step toward understanding the universe, its origins, its destiny, and the fundamental laws that govern everything. This concludes our journey into black holes, where the extreme and the unknown meet, leaving us with awe, curiosity, and a deeper appreciation for the universe around us.